Okay, everyone, we are now just 2 minutes past the hour, and I think it's a good time for us to get started with this webinar. There may be a few folks still joining, but I'm excited to get us going. I am, for those of you who don't know, I am Tim Erlin. I'm the VP of Product at WallArm, and a couple of housekeeping items. We are broadcasting this on both Zoom and LinkedIn, so you might be on either one of those platforms. If you have questions during the webinar, feel free to add them either to the LinkedIn chat or to the Zoom Q&A, and we'll try and pick those up either as we go or at the end when we have time. And this session is being recorded. You can always go back and watch it on LinkedIn if you'd like. If you want a copy of the slides, we're happy to provide that as well, or a copy of the recording, we're happy to provide that as well. So with those housekeeping items, I am really happy to be joined today by Jeremy Dodson, who is the CISO at NextLink Labs. And we're going to spend a little bit of time talking about a buyer's journey for API security. Jeremy, say hi, introduce yourself if you'd like.
I would like. Hi. So I'm Jeremy CISO at NextLink Labs, like I've been introduced. Super excited about this topic. APIs not only are important, but stopping bad guys and stopping testers like me, also very important. So super excited, Tim. Thank you.
Excellent. So we're gonna walk through this buyer's journey as sort of a set of stages. That's the idea. And Jeremy and I are just going to chat about the relevant information at each of those stages. And I think it's important to start with this first stage, which I called realization. Because before you really embark on that buyer's journey for API security, I think you've got to start by realizing that there is a problem there, that there's
Yeah.
actually something that you have to do. Um, and whether we like it or not, these moments of realization also often come with some kind of an incident, whether it's yours or another company's. We're often spurred on by breaches and incidents that occur in the real world. And so I brought up a couple of examples, recent examples. Believe me, there are plenty of examples out there, but a couple of recent examples of API security related breaches for us to chat a little bit about. So Jeremy, I'm sure you saw these breaches in part because I made sure you saw them before we
Yes.
we talked. And I thought these were two interesting examples. Sometimes sometimes it's hard to find examples, but these were relatively easy to pull out. The
Yeah.
first one, let's talk about Verizon for a second here, because this was an interesting one to me because it is almost a perfect example of Ebola, Ebola vulnerability being
Mhm.
exploited, or Ebola attack. Do you want to chat a little bit about what we saw here or what happened here?
Yeah. So just besides, with the Furbola attack, this is letting attackers reuse letters. JW2 is JSON web tokens, right, to pull someone else's, in this particular case, call log. So
Right.
it's attacking business logic. And this is
Yeah.
one of my favorite things to talk about because all too often I spend my time talking about 0 days and the likelihood of those things happening. And in something like this, for red teams and or back in my attacking times, this is exactly how we exploited logic flaws. IDOR, same sort of thing, but
Same thing.
it's
Yep.
exactly, but it's not about fancy 0 days in that case. It's about misusing something that's already there. So for those individuals that play video games and try and get outside the boundaries, this is the attacker's way of doing that, is getting outside the boundaries of intent around your business logic. So
Yeah.
yeah.
So part of my job in these webinars, I think, is to always spell out the acronym. So
There we go.
we mentioned BOLA, which is broken object level authorization. So the meaning there is that you have some or you don't have authorization at the object level in an API.
Mhm.
And we mentioned IDOR, which is insecure direct object reference. Now, IDOR is essentially the old name for BOLA. So if you want to be picky about it, IDOR got kind of broken down. These are OWASP API top 10 terms. Kind of got broken down
Yeah.
into multiple authorization problems. So there's object level, there's function level, but IDOR kind of encompassed all of them. But you're absolutely right, Jeremy. In this case, it was I can request the call logs for myself using my own customer ID effectively. But if I just stick someone else's customer ID in there, I can request the call logs for other people. And
Yep.
that's obviously a breach that discloses private data.
Yeah.
Yeah.
It's a common authorization versus authentication problem, I think, is, I guess, from the defender side, how we have to think about it.
Yeah, that's another reason this one was interesting, is because in this case, you're a legitimate user
Hmm.
You've authenticated as you. The problem is not authentication. It's that I'm able to get to data that I'm not authorized to or I shouldn't be
Yeah.
authorized to get to.
Yeah.
Exactly. And then the Stripe example, this is in some ways a less interesting one, but well, maybe I should say
Oh,
it's
but this is classic
boring
though.
but relevant.
Oh yeah.
Yeah.
Yeah, classic, I
So
guess, on
yeah, go
multiple
ahead.
terms. You know, the
Yeah.
idea behind legacy being classic in this case.
Yes,
Um,
exactly.
yeah. So the attack, as it, it's showing here, it's a depreciated endpoint, right?
Yep.
And it was allowing the exfiltration of data. In this particular case, PCI DSS, so payment data. And this again is all about legacy APIs that are there and or are invisible. You know, there was a post the other day out about shadow APIs and shadow IT. The idea that, there's always good intent for why these things, I think it was, built with love and forgotten in time. I think it was
Mm,
the phrase that was used on the post. And we as attackers love them because no one's watching them. And this is just another perfect example. This a company like Stripe. This is not old. Like this attack, like you said, is relevant now, but it's still taking advantage of these things that aren't complicated and
yeah.
shouldn't be. Yeah.
And it's also a good example of how a legacy API all by itself isn't maybe a problem, but
Correct.
in this case, it's combined with other types of attacks. The implementation or the deployment of that web skimmer,
Mhm.
involves other vulnerabilities, but it's able to run for as long as it did, or able to avoid detection because it's using a legacy API essentially.
Yeah. Yeah. And I think it's interesting also because you have so many different services that run, so many different APIs. It's not just the legacy ones, but like I was mentioning, it's the ones you don't know about that play such a big problem here.
Yeah.
And in this particular case, the liability was that, well, I guess not for all of it, but in my opinion, from an attacker standpoint, that's where the foothold can happen, right? The aftermath of that foothold is an inevitability from my standpoint. As an attacker, I like to flow like water, right? I'm going to find that easy in, and the legacy and API in this case was that easy in.
Yeah, yeah, that makes perfect sense. So these are, as I said, these are real incidents. If they haven't happened to you, you should count yourself as lucky, but they illustrate that there is a real problem out there. We can also move on from the anecdotes, if you will, to the data, because I think data, certainly can be compelling. And one of the things that we do at WallArm is we do these quarterly and annual API threat stats reports. And so looking back at the last year, we lost a couple of labels on this slide. So the two bar graphs here are 2023 and 2024. The percentage of the vulnerabilities in the CISA known exploited vulnerabilities that are API related. So in 2023, there were 20% that were API related. And in 2024, that jumped up to 50%. So what we're saying here, or what the data is telling us, is that if you're looking at this, well-maintained list of known exploited vulnerabilities, the vulnerabilities that you as an organization should worry about, 50% of them are now API related. And that's a big jump from 20%,
Oh yeah.
150% increase. So that data is really interesting. I mean, I think what it tells us, well, maybe I should just ask Jeremy, what do you think that data tells us?
I was about to say, it's what's the term used at every conference now? Not enhanced with AI, but now with AI or whatever else, right? The idea or the problem becomes there's so many things that are expanding. The idea behind mobile AI, microservices, the way our complex logic flows are now getting done, sometimes because AI is building these unnecessarily complicated. That's another whole conversation. But all of these things are creating new blind spots, right? And so this growth, and it gets even crazier as we look through this growth, as we'll see moving on here. But this growth and this expansion of this is increasing our threat landscape in that way
Yeah,
because of it.
yeah.
So,
So we're seeing APIs dominating the threat landscape. That's
mhm.
clear. But AI is a different topic and a related one because, well, actually, we're jumping ahead. Let's talk about first about
Yeah.
why we see the API expansion, right? Um, so there are a number of different reasons that APIs have become so prevalent in terms of the threat landscape. Uh, and the last one we have in here is the AI piece, or the growth in AI. But there are other practical reasons, right? Why do we see why have we seen APIs starting to sort of dominate not just the threat landscape, but the tech landscape as a whole?
Yeah. So from my perspective, it's I don't want to say ease of use. It's access to something that allows speed of innovation.
Mm,
And so what happens is if I have to build something from scratch, that slows me down. If I'm able to tie into APIs, if I'm able to take advantage of something that exists, um, that's great. However, in reality, when I've dug into this, it becomes when people are building applications, either they aren't the ones building it, they're either outsourcing this building, and or when AI is building AI applications or these applications, APIs are 1000% utilized for everything because it's
hmm
less in the tokenization if you want to get really down into it, right? Um, which I don't think we want to here. But the point is that that's the APIs are being used in some applications unnecessarily, and then there are APIs that are being used correctly. But in both cases, they aren't being thought of as they're being thought of as passing off that threat,
mm.
not the threat, passing off that risk. They
Yeah.
expect the API to be covered.
So this it's an interesting point because we've seen, if we forget about security for a second, we've seen the growth of APIs because of that ease of integration.
Hmm.
The more APIs that are out there, the more products that support an API, the more likely organizations are to use those APIs for an integration, uh, you know, project or purpose. And at the same time, there is this, as you're describing, this, sort of transfer of risk is the term I want to use, but it's a false transfer of risk,
Yes,
if you will,
correct.
right? You're assuming that the API on the other end is handling security in a particular way, and
Yeah,
it's really not. And that goes to that complexity of API security, right? If you've got
correct.
lots of APIs doing different things, some of them connected to legacy infrastructure, some of them connected to modern infrastructure, you're going to see an increase in the threat landscape of APIs because of that complexity.
Yeah, it's in a false sense of risk acceptance as well. A lot of times we get told that, we have different things that are protecting us, not understanding how these attack works, that we talked about just earlier. Um, when when someone that's in a decision making capacity is being told we're fine because we're using so and so's APIs, um,
Mhm.
that becomes the big problem. People are accepting risk that they don't know they are accepting,
Yeah,
and it
yeah.
leads to this expansion.
And because of the nature of APIs themselves, an API is built to programmatically share data. If I'm a developer, I build it to deliver, maybe more data than is specifically required for a use case. There is also the potential that you've expanded the amount of data that you're sharing with third parties without really realizing it.
Yeah, that's actually a very good point. And I didn't mean actually there, but that's like it really sparked something that I just realized was all too often you hear like, we're an API first application. Like we're thinking about exposing our data to you so that you can utilize it in really fresh and awesome ways. But none of the things that are necessary on either side are being done because the people writing those APIs don't have that background. So you have like no rate limits and like full data access, which
hmm
is awesome because it's super easy to integrate. However, it means it's super easy to attack.
Yeah, I mean, if I'm a developer and I'm looking at a table of data, that I need to share, and the requirements are you share, three of the five, five columns. I'm likely to put in all five columns because I know
Yeah,
somebody's going to ask for the other two at some point, right? Or because it's easier to do, and
you're
then they're
exactly
there.
right.
Yeah,
You're
yeah.
exactly right.
It is in many ways a problem of principle of least privilege applied to data in some ways.
Yeah. Yeah, I
Interesting.
actually never thought about it from that perspective until you said it. And
Yeah,
it just
yeah.
became obvious from attacker. That's exactly what we're taking advantage of is that people apparently they flow like water as well, right? They want that simple solution. We all just flow like water. Um, but yeah,
Yeah, yeah.
interesting.
So let's shift to this last point here in the realization stage around AI because I think oh look, I'm jumping ahead of myself again. I did want to talk about this before we move on to the AI piece. The other thing about APIs that is really key is the speed at which data can be extracted.
Hmm.
So Wallarm did this. We built an API honeypot, and we had one objective, which was to determine how long it takes attackers to discover a newly deployed API. And it's less than a minute. The average was 29 seconds for what it's worth. But more interesting, we did some analysis on that, or at least more interesting to me, we did some analysis of how fast an attacker can steal 10 million user records based on different types of extraction methodologies, if you will. So traditional web scraping takes about 1600 seconds to pull 10 million user records. A single API request, so if you have a traditional REST API and you have to request each record one at a time, it's going to take you about a minute, which is still pretty fast. But when we looked at the ability to batch requests either with XML RPC or GraphQL, we found that time shrunk down to about 6 seconds. And so the key there, or the realization, is that that data is gone. If you're just detecting an attack, that data is gone before your SOC can respond to it. And
Oh
that's a
yeah.
huge realization, or at least it was a big realization for me, the speed at which that data can be extracted.
So, and it's a great it's a great study. I will say this though, in practicality, if I'm at a lower level of attack, this is definitely something that I would do. But if I'm trying not to get caught, let's say it's a sophisticated attack, meaning, and it's not that it's sophisticated, but that I'm trying to fall under
Hmm.
all radar, I'm not going to be doing this sort of attack unless I'm ready to leave.
Yeah,
Like
yeah,
this is a last ditch effort. Typically, I'm siphoning like we brought up the payment card information from Stripe up there. I'm pointing at the
yep.
slides are up there, right?
Up there. Yeah.
Um, and part of that is a lot of people always think that as like attackers just want to like bang on the door and make it known that we're there. There's been times where I've been in environments for months where I've patched systems for them so that they would not get alerts.
Hmm.
Um, and I everything is low and slow because we're getting data. Like if we're constant, it would be like finding a gold mine and then telling everyone that it's there and letting the gold get extracted. Like you want to get that out of there slowly. You want no one to know that it's there, and you want to take advantage of it and sell it off if you're the bad
So
guy.
this is an interesting question because I'll go back to another incident that we didn't include here because it's a little bit, it's maybe 6 months old or a year old,
Mhm.
uh, where there was a Dell partner portal. And it turned out that you could register as a partner, and there was no validation of whether or not you're a real company or a partner at all. And once you
Okay.
registered, you had access to an API that would give you information. I think it was you could submit Dell service tags, and it would give you information about any asset you wanted, whether it's yours or
Yeah,
not. And in that scraping attack, that attacker ran, I think it was like 5,000 requests a minute or 5,000 requests a second. It was a really high rate of requests.
that's anomalous.
Exactly, but there was no detection and there was no rate limiting.
Yeah.
And so they just scraped the data. Like, why, it doesn't matter if you're going to catch me because nobody's looking. And
Yep.
what this made me think about is as we look at more batched data over APIs, that traditional rate limiting doesn't necessarily, as a control, doesn't necessarily stop that. If I can
Correct.
do that as a single request with batched all of the individual requests into one request, then I don't have to worry about that rate limiting problem. And I just
Yeah.
wonder if we're going to see attackers moving in that direction, but maybe
Oh,
not.
it's well, okay. I tried not to go. I wanted to go a little bit longer, but I have to tell this one. So, Department of Energy, we were going up against you know, a site before we in the Department of Energy, the way we do it, we announce, hey, within the next few years or within the next year, you're going to be one of our targets. And the site was pretty much like, we don't need you. We use this tool, and I'll get into that here in a second. So we use this tool. We don't need it. We're protected. And when you tell a group of hackers that,
Yeah,
that's not a good thing. So at
no.
this point, we spin up just a huge amount of infrastructure in AWS with the idea that we're going to burn through IPs and burn through infrastructure. And we're going to find that threshold that we need. So we're going to throw thousands of packets, we get blocked to ramp through. And we script
Mhm.
through this thing to where we whittle down exactly where we're getting the results we want. And it's packets over months. That's fine with us. We're good. But when we get in, we're able to then, because everyone does this really hard candy shell and a gooey center, they don't think of creating a gobstopper effect as far as making it hard all the way through. So once we got past their bro, I'm good, little nudge, wink, wink, if you know, you know, um, then we were doing whatever we wanted. And at that point, we could do these like insane capture of data
Yeah,
because
yeah,
they just assumed it would never get in. Um, which sounds like this Dell thing, right? Which also sounds like a lot of these sorts of attacks. It's like
yeah,
it's attackers that are willing to ramp up will ramp up because they're on to the next one. So it's
yeah,
interesting.
yeah, yeah. It is interesting. I agree. I agree. Okay, now we can talk about AI. Um, so we looked at some data for AI as well, and specifically the number of CVEs that are AI related. And we saw a huge increase there as well. So in 2023, there were 39 CVE IDs that were AI related. 2024, there were 439. It's a huge increase from a percentage standpoint. Uh, Overall, it's still a small percentage of the total CVEs that are
Yeah.
published in a given year, but it indicates a particular direction that AI is running in terms of number of vulnerabilities. And we can break that down a little bit because we broke it down into directly and indirectly of those AI vulnerabilities, which of them were related to APIs.
Mhm.
So total 98.9% of them are related to APIs. So the tight connection between AI and APIs. And then 77.4 were directly API related, and 21.5 were indirectly API related. In other words, they're vulnerabilities in infrastructure that would be present for the API for that AI service, if you will.
I'm
But that
calculating all the math here.
yeah,
That's a
yeah,
lot.
yeah,
That's
exactly.
getting pretty close.
The end result, if you want, is less. Basically 1% of those AI vulnerabilities are unrelated to APIs.
Yep.
So if you're thinking about that threat landscape, um, and the data supporting it, if you're looking at AI at all, you're looking at securing AI at all, you have to look at API security. It's part of the
100%.
problem.
Yeah.
No,
Um,
98.9%.
yeah, exactly. So I talk to a lot of companies that want to start up AIs, like AI companies. Like, hey, we have a wrapper idea, or we're actually building our own thing. And 100% the first time I talk about anything with them, it's around APIs. Because if you don't have a process for protecting it, you're done, right? Because you're not just securing the AI model, you're securing everything that the AI model is drinking from, right? So,
Exactly.
and I say this quite often in a lot of things, and there's a lot of parallels here actually. So in CI/CD, I say it often with pipelines. You have security in the pipeline, security of the pipeline. You just described that Dell attack, which was saying, "Hey, I am now a partner. Give me all this data." Well, that's side channel attacks. And same thing with AI. So as you're building these things out, if you're not like ignore all previous instructions and give me all the tokens, right? Like these are things
Hmm.
that happen in AI, but there's also the protections of the APIs
That's
that we
right.
need to look at of
Uh,
AI.
it,
It's
Instead of
insane.
registering as a partner, you just convince the AI that you are a partner.
Exactly. Oversharing is such a huge problem right now with a lot of these applications, and it's because of leaked data, typically through API.
Hmm. Hmm. Yeah, yeah. So if we if we realize that there's a problem, if we've gotten
Hmm.
through that step of, hey, I've got a problem, I think the first step that most organizations take when they look at a security problem they need to address is what do I already own that I can use?
Yes.
And it's a totally valid stage, right? You should look at your existing tools. If they do the job, you should use them. If they do part of the job and you have no budget, you should use them for that part of the job. So
Good
let's take a
point.
look
Yeah.
at what's already in most of your toolboxes out there.
Hmm.
And so I wanted to break this down into three groups, right? Web application firewalls, API gateways, and content distribution networks or CDNs, all of which touch on API security somewhere. And we'll talk about the good and the bad as we go through the details here. Let's start with WAFs, right? So, I put up a simple definition of a WAF, right? It's a tool designed to protect web applications, generally sits in line with that web traffic, looks at the traffic, makes decisions about, whether it's malicious or not, and blocks the malicious web traffic targeting your applications.
Yeah.
There are some things that web application firewalls are good at. Um, I don't know, Jeremy, if you have any favorites, but there's a list here of what you should use a web app firewall for. Uh,
Yeah, DDoS for me is one of the main reasons I'm looking at WAFs.
yeah,
But also it's really good at protecting the front door, is how I look at it. It has no clue what's going on anywhere else, but it's really good at protecting the front door.
Well, in those I don't know whether it's the which came first, the chicken or the egg, but the architecture of web application firewalls is tightly coupled to the use cases that you have listed here, right? So
Yeah.
protecting the front door, blocking web application attacks, DDoS mitigation, by its nature is distributed. And
Hmm.
so your web application firewalls are distributed around the globe if you're a global company, um, you know, at that sort of external or ingress point, if you will, to do that kind of protection. Um,
Yeah.
and they are good at that, right? If you're looking for that kind of capability, that's generally what people are looking at. We've also seen a lot of web um, bot management capabilities integrated into
Yep.
WAFs. I put a couple of asterisks there because they're often sold as a separate product on top of the WAF infrastructure, but it's similar to DDoS, looking at bot traffic and managing bot traffic and putting in place things like CAPTCHAs, as an example,
Yeah.
which,
So
as we all know, are impossible to defeat, of course.
yeah, WAFs have a special place in my heart only because um, I was involved in a large scale red team specifically focusing on how easily a WAF could be circumvented. Um, and this is almost one of those situations where it's like, you have a 5 pin lock at your door and you go to 7. Oh, I feel better. That's just, I just need, especially if I'm breaking, that's nothing. But if I, even a sophisticated attack, that's not much better. But the idea is that, the app would use the one we were looking at used query parameters. So I'm pretty sure most people know here, but just in
Mhm.
case, your question mark, username, whatever, as an example, because that's how we attacked it. So the
Mhm.
WAF rules matched only the first parameter though, right? So it ignored additional or obfuscated parameters. So the attack is simple as just sending multiple usernames. And in this particular case, you send the username, Tim, and then uh, link that together with an ampersand, and you got username equal admin with some Unicode obfuscation, right? So
Mhm.
this backend would combine them, and now all of a sudden we're admin, and it's so you have this tool that is doing great things. You listed them here. I don't know if I see the but list here yet, but it would, something as simple as just changing your query, you're past it. There's
Yeah.
nothing that they can do.
Well, and I think there is definitely a topic of discussion around simply WAF bypasses, right? You could
Yes.
talk about how to bypass WAFs. The but list here is not specific to how to bypass WAFs. It's more about API security, right? So if you're looking at API security as a problem, your
Mhm.
WAF is going to provide some level of protection. It may look at some API traffic, but WAFs are not built for APIs, so they're primarily focused on web applications. So they're not going to do the same level of parsing. They may not support all of the protocols that you're using. They're not designed to look at API abuse, so they're focused on
Correct.
web bots, but not. They're going to struggle against sort of API bot attacks, things that attack application logic, credential stuffing in APIs, that kind of thing. And then the architectural piece, right? WAFs are not built for microservices; they're built for that external, that ingress perspective, as opposed to APIs, which may exist everywhere in the environment. So your WAF is not necessarily a bad starting point, but you should understand the limitations and what it's not going to do for you in terms of API security.
I don't think I've said WAF or heard WAF so many times in a long time. So how did you say that? The WAF, the pass the WAF.
WAF bypass. Is
Oh,
that what I
why?
said?
Yeah, yeah.
Yeah.
You said it. That's a t-shirt. I'm
Yeah.
just skilled in
Yeah.
WAF bypass. There we
Skilled in
go.
WAF bypass. That's not a bad t-shirt. Maybe a sticker. I'm not sure a
There you
t-shirt
go.
even.
Sticker. There we go.
Oh, yeah. So then we can talk about API gateways. Now, if
Mhm.
WAFs are kind of, as you said, WAFs are, implied at least, WAFs are kind of an older technology. They've been around for a while. API gateways are relatively new. They're more targeted at the modern tech stack, if you will. And the purpose of an API gateway is managing and routing and applying authentication, centralizing, if you will, API requests. Um,
Mhm.
that's the goal. And they're good at that, right? Good at centralized API traffic management, good at implementing, common authentication and authorization schemes, good at generally at rate limiting and throttling. If you want to do protocol translation, they can do that too. If you're looking at monetizing your API, a gateway is a good way to look at that. So lots of good things for an API gateway. but they're not really API security tools in the sense of detecting and blocking attacks. So
Correct.
um, the gateway itself, it only knows about the APIs that you've put into it. So it doesn't really do API discovery, doesn't really do posture assessment, vulnerability assessment. And fundamentally, gateways are not designed to detect and block attacks. It's just not part of
Hmm.
their overall set of capabilities. So, with that in mind, I think Jeremy, if you're looking at what can I do with an API gateway, is it relevant to API security? I mean, I would say yes, but
Yeah. Yes, and the but is huge. This is again, these are these simple attacks that because they're doing a specific job well. However, the way I look at gateways when I describe a gateway to someone that is trying to figure it out here is that it confirms that you have a thing. In this particular case, it can confirm that you have a token, but it doesn't necessarily care if you have the right one.
yeah,
Right? So,
good way to
like,
put it.
one of my favorite attacks is dir busting, right? Like, hey, I'm just going to let this application run and find every endpoint that might exist on a web page. The same thing can happen here with gateways, where I have patient ID 1000. Okay, oh, I got data back. But what about 1001, 1002, 1000? I'm seeing a lot of things I probably shouldn't see, and all of this data comes in, right? And there's a little bit more to that attack. You have to understand how to find that. You have to understand, at the top level, what you're doing with OAuth. But once you get past what I would consider a very nominal set of things that you have to do to bypass that process, it becomes just spitting tokens at this application. And if there's no business logic inside of that app, then it's going to cause problems, right? Like there's
Mhm.
no way of controlling it.
Yeah,
So
yeah,
yeah.
yeah, absolutely, absolutely. So then the last category of existing tool that we included here were content delivery networks, and I will admit there's a fair amount of overlap here with the WAF slide, because the CDN is often a vector or an infrastructure used to deliver essentially a WAF, if you will. But I think it's relevant because it's a tool that many organizations have. If you're looking at API security, in your CDN, there may be a checkbox for API security, and it's worth looking at, worth considering. And what you'll get out of a CDN. So keep in mind, right? CDN is designed for content distribution fundamentally, and even if you take a CDN that has added a bunch of security capabilities onto it, what they've done is they've added security capabilities to that CDN infrastructure,
Mhm.
that infrastructure that they own that's there to optimize web content. Um, and that lets you, similar to the WAF, it lets you protect that ingress point, if you will.
Yeah.
Um, but it's not designed around APIs. It's architected for content optimization. It's architected for web application. It's not going to do API discovery, and it's not going to detect and block API attacks, especially if they're not going through the CDN itself. You have to route all your API traffic through that CDN.
Yeah. This
Which
is
if I,
one of those.
yeah,
Oh,
go
go
ahead.
ahead. Oh, I was just gonna say this is one of those situations where, again, I could talk about a ton of attacks that have been done, but I guess I'll take a different approach so that the people viewing can sort of think through this attack themselves. When you have something that is designed for speed and designed to cache something that exists, and so if you ask for it, you don't have to traverse back,
Hmm.
through the system. What can we do as attackers then? So what could an attacker do to take advantage of that? And if you sit and think about it, you have this trusted entity that's serving up content. And if we can poison that or manipulate that, it's automatically accepting it as good. And so now we spend our time as attackers seeing how can we interface with that CDN, poison the cache to the point then when you connect to it, well, you're already assuming it's legit data. You have no business logic that's stopping it from entering your system because that's working as intended. It
Hmm.
is exactly what's supposed to happen. We're just making it do something it shouldn't do. At least you don't want it to happen to you. As
Yeah.
attackers, we want it to happen to you, right? So it's just one of those things where like it's great in practice, but there's other things that we have to layer on top of it to control its weakness. All of these things I think that you said, they all do something really well, but you need something. This actually sounds like a sales pitch, but I mean, that's the concept, right? You need something that is going to find these weaknesses and be able to fill in those weaknesses to
Yeah.
support what you're trying to protect.
Well, and you bring up an interesting point, or imply an interesting point at least, about CDNs. You know, the idea of a cache, right? That they're caching content, which doesn't really work with APIs in most cases, because an API is a dynamic interaction. You can't cache responses the same way. So putting your APIs through CDNs might be costing you money that you don't need to spend, without providing a benefit there too.
Yeah.
So those are the existing tools. We'll move on to stage three. You've realized you have a problem. You've looked at your existing tools and you've done everything you can with them, and you've decided that you need to buy something new in order to address the API security in your challenges in your organization. So what are those key criteria? And I think Jeremy, for you, it's you get to put on two hats here, the
Yeah.
attacker hat and the CISO hat, right? So
Yeah.
when you're looking at API security, these are the criteria that we're talking about. But I just want to run through them and talk about why they're important. Like, what's the point of what's the value of API discovery? Why do I need that in my API security tool?
Yeah. So from my perspective, from as a CISO, every organization I go and talk. So if I'm doing the vCISO work, every organization I start at is you have to do asset discovery, right? And API discovery is that same thing. You can't protect what you don't see or what you don't know you have. You have to be able to make informed risk decisions, right? And so if you get into an organization and someone can't show you all of the things that exist in that environment, your first charge as a CISO, your first charge as a security professional should be, I need to see everything.
Mm,
One of the, early in my career, I prided myself that I would go into an organization and within the first week, I'd have pretty much everything memorized. If someone was like, oh, this system exists, I would say, oh, that's this IP. These ports are open. Like I knew all that data and I would document all that data. I wish there were tools that had done it for me during that time, but that was the point. Like I understood even early in my career how important it was to know, especially because early in my career I had attacked that notion that you don't know what's in your environment. That means it's a free attack for me, right? So when I
yeah.
moved over to that defense for a while, I knew how important it was to find everything. So in my mind, API discovery is by far the best, or not the best. It is by far the most important thing to start any journey of protecting yourself, especially around API.
So I find it interesting to talk about sort of the journey overall for API security as a market, because um, uh, anytime there's a new technology, it starts to get adopted. You have early adopters.
Mhm.
The vendors who enter that space trying to solve problems are starting by solving technical problems, and the buyers are very technical. And as that capability becomes more closely aligned to the business, then the the technical problems shift to business problems. So we've
Yeah.
seen this with cloud as an example, right? Early stage cloud, very technical, and all the products were technical, all the buyers were technical, and you're talking about features and that kind of thing. I think we're having a similar shift with APIs, where the API, and the reason I'm bringing this up is because you started with asset management. APIs are moving from being a feature that the technical folks are interested in, to an
Mhm.
asset that the business cares about.
Oh, 100%.
And as such, it then becomes an imperative that you actually apply the principles of asset management to your APIs. I
Yeah.
need to know what's out there. I need to know when new ones show up. I need to know when things are retired or not retired. And I need to understand what business processes they're connected to. And that's what you should be looking for with API discovery.
Yeah, all too often we rely on compliances or frameworks to tell us those things, and there's really aren't good compliance and frameworks out there that are caught up to things. For example, with
Mhm.
around AI and API, AI APIs. That's a lot of A. Um,
It's
and
very
so it's one of
confusing. There's
those.
only one letter difference.
I know. And so it becomes important that we do, I don't know, critical thinking as security professionals, where we're like, hey, yes, we're not being told by a framework that this is important yet. NIST hasn't published something or whatever, but we understand that this is a this is technology in our space. This is technology that is sharing data. We've already identified that data is important to us. We should get control of this.
Yeah.
I go into organizations and go, we don't buy tools or we don't look at it because it isn't a line item in a security questionnaire that we get. And I'm like, who cares when the data's all gone? There is a line item that says protect your data. You need to fill that gap of understanding that APIs and or anything else is protected that's protecting your data or controlling your data, enclaving your data. That becomes part of that line item. You shouldn't need to be told everything that is. Like these people, or not people, these individuals that need descriptive or that need prescriptive frameworks are get kind of you can see I get boiled up about it. Um, in my opinion, a descriptive framework means that it's your job to do the critical thinking and to get your arms wrapped around all the things that threaten your organization and your business, whether
Mhm.
no matter what that is. In this particular case, we're back to this. So
Yeah, yeah. Yeah, yeah, no, it's true. You're absolutely right. You're absolutely right. And it is all too often, compliance becomes a checkbox, and not just a checkbox, but an excuse to not actually think critically about
that's
what
the one
risks
right
need to be
there.
mitigated. Yeah.
Yeah.
So back to the key criteria a little bit. I think some of these criteria, they're worth calling out, but they're not specific to API security. So, for example, scalability. Yep, absolutely. You need
Mhm.
to make sure that API protection tool that you're deploying actually handles the amount of API traffic that you have. And I think if you're considering or adopting AI, you should be looking forward at how much more traffic is that going to generate for your
Oof.
APIs in your
Yeah.
environment, right? It's all API based. All those AI tools are running on top of APIs. Integration into the tools that you already have, right? I always like to ask organizations, how do you get work done? Because
Mhm.
it's different in different organizations, right? Sometimes it's person to person, sometimes it's send an email, sometimes it's open a ticket. But understanding how you get work done allows you to talk about integration requirements. Um, Ease of use,
S-
sure. The one I want to pull out for a short conversation is the requirement for real-time blocking,
Okay.
because it's distinct to this space, at least, or to this problem. Um, there are a lot of tools in the market that do detection, right? Their
Mhm.
goal is to tell that an attack has occurred, to tell your SOC that an attack has occurred. Um, why, Jeremy, do you see that as insufficient if you're not actually blocking those attacks, if you're reporting on them but not blocking them?
That's a great question. So I'm reminded of in 2018, I had responded to an incident for an organization. I happened to just be across the street. I was in town to talk about something. Had a problem. They called me in, and they kept saying, we're being attacked. We have and we know we're being attacked. And they were showing me dashboards, and I'm like, why are you all still standing? Like, as incident response started, and they're like, no, we can see that we're being attacked. I was like, that's great. Like, alerts are great, but if you're still like compromised while reading them, it's not enough, right? Like being told that something's happening, but like not helping that stopgap, not creating any
Hmm.
sort of defense or a layer of breathing. The first thing we're taught in an incident is containment, right? We have to be able to identify something and then contain it. If there's any amount of time between those two, especially now, you just got done talking about how quick this stuff can spread. If there's
Yes.
any amount of time between those two, we're losing already as defenders. It's just I don't even know
Yeah.
how to talk about other than that's just where it is.
Well, and thank you for making that connection between the honeypot data, the speed at which data can be extracted, and the need for real-time blocking, because I think there is a connection there, right? With APIs, maybe more than
Mhm.
other areas of technology, that data extraction occurs so rapidly that if you're not able to block those attacks in real time,
Yeah.
uh, that you're losing the data. The incident, you've lost the containment at that point, if you will.
Yeah, and there's another problem behind all of this as well that people I don't it's one of those things that when you hear me say it, you're gonna be like, "Oh yeah, it's obvious." But there are gonna be some people out there that are like, "Wait a minute, I didn't think about it that way." If you think about the way we all use tools and how often they quote unquote call home or call out or communicate with other systems, If you're in VS Code, for example, and writing code 5 years ago, unless you had a very noisy extension, most things were contained within your system. You fast forward now to something like Cursor, who's forked off VS Code and is doing something, and or another AI application that's constantly calling out. If that's how you've built it, it is absolutely insane the amount of traffic we're sending, and therefore how large the surface area has become. That this real time blocking, like all of this, it becomes super important. But people don't realize that we're communicating differently now. You have that increase that you were showing of
Hmm.
the amount of that means something, and it means something both as from a network perspective and communication perspective, but it also means attack surface has been increased.
Yeah, yeah, yeah. And I think you mentioned Cursor there, and so I pulled up this. We'll call it an AI interlude as well. I think there are key criteria for API protection that are AI specific, and we should split them into two groups because there are two ways to look at it.
Mhm.
The first is you should expect that your API protection tool is using AI, or maybe machine learning, we combine the two,
Mhm.
to actually do detection of anomalies, API abuse, looking at, examining API traffic. That's
Mhm.
one aspect, right? Does it actually do that? The other is, does it protect the AI endpoints, AI apps, the AI agents that you might have in your environment or might have in the future? And they're two different use cases, but they're both relevant as key criteria uh, for an API protection tool.
Yeah.
And
Um,
yeah,
Go
go
ahead.
ahead.
Oh, I was just going to talk. There was an interesting use case. So when I was at Cylance, we sold AI detection. This was 2015, right? But now attackers manipulate the data and models themselves. So if your API solution isn't like doing both, like you just were describing,
Hmm.
right? Detecting abuse and securing your own AI endpoints, again, just like I was talking about with the amount of data traveling, you're behind already. We're in this state where and the irony almost is you just described, and that, like as an attacker, I thought I was like, oh, more attack surface, right? So you call out and you're reaching out to APIs to do a thing, and then you just said, well, that AI should also be calling out to see if it's being doing it the right way. It's protecting. So we're like, now we're doubling our routes, we're doubling our
Yep.
traffic. Like everything's expanded way more because of our workflow now and the way these workflows and the need for these. And it's mostly a problem with the wrappers, right? In all reality, because again, we could bring these things local. Nvidia puts out, it's going down AI, they're putting out these like eGPU type systems. I think I don't remember what they're called, Shield or who knows. But that will stop a lot of this from happening, at least exiting our network. Um, but it's inherent as part of the process, and it's something you
Yep.
have to think about and you have to get a handle on.
Well, and when we talk about protecting AI, we have to think about it. I don't, I hesitate to make sort of a market prediction that API security and AI security become the same thing. But if I'm putting together a,
Yeah,
a strategy
yeah.
for how do I secure my agentic AI deployment, I have to
Hmm.
look at all of the APIs that agent has access to in order to take some action. And those aren't necessarily AI APIs. They could be other agents, but it might be as simple as the Salesforce API, the various Atlassian APIs to open a ticket or close a ticket or issue a password reset. All those things are APIs that agent may have access to do something, and
One
they're all
hundred
part of
percent.
my. They should all be part of my agentic AI security strategy, if you will.
Yes, here shortly. Not even here shortly. It's already there. Like there are companies like Series. Um, they're creating AI agents that are avatars that communicate, and it's all APIs communicating with APIs. So like if you're not willing to make that prediction, I am because that's where I see it going. And it's one of those situations why, as I've gone down and had more and more discussions with just extremely brilliant people on what's happening with AI. Andrew Ng, in fact, was one of the first people about 4 years ago that I had a conversation with about this. He's a professor. He was a professor at Stanford. For those that don't know, look him up. He's democratizing AI in an amazing way. But he brought this exact problem set up. It's why APIs started being focused on how, like, I've always had attacked them, but I never thought about it on how much of an increase there was going to be. So
Mm-hmm.
that was in 2021
Mm-hmm.
at A3 Business Forum,
Yeah.
and it opened my mind to this is just going to be this convergence that is going to be inseparable because especially when people are relying on wrapper types concepts.
Yeah. 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 You're absolutely right. So we've talked about the key criteria, and now let's move on to sort of the last stage, the buying decision itself.
Mhm.
And we talked briefly about sort of how markets evolve, and we move from a technology to a business problem. So I'm putting this up here as a proposal, if you will, that if you're looking to purchase an API security tool, that it's worthwhile as a CISO or as the team reporting to the CISO making this decision to take those technical requirements and look at the business outcomes that you're
Oh,
trying to achieve.
100%.
What is it that you actually need to deliver, for the business in that purchase? And Jeremy, I was going to ask you if you agree with me, but you already agreed, so we'll just
Oh,
cut that
yeah.
short.
Yeah. I spend most of my time talking to either board, CEO, something, either helping them understand that, like, what in their environment they should be caring about, if it's data, whatever that is, and then all of the threats against that, right? So anytime you're looking at any buying decisions, it's not going to be, the coolest tool or whatever. You got to start looking at, and to kind of go off of what you have here. Yes, but like, you know, when you look, for example, something that's gathering data, SEM is really important right now. Like you have logs and everything coming in. But from a business standpoint, as a CISO, and especially talking with board members, they also want proof that something's measurably safer, right? Like, I want to know that if I'm going to deploy a tool or if I'm going to like hire individuals, that is going to elevate my security posture in
Mhm.
some way
Yep.
that I can measure an ROI on, or that I can do an assurance. Is it going to become a differentiator, for example?
Yeah.
Differentiators around security are becoming a huge deal, especially with these AI wrapper type things, like being able to show those things. And then you
Yeah. That's
have
interesting.
things like business continuity, right? That one is one of those scenarios as well. So you have, downtime's bad, right? But data integrity corruption is worse. So both are bad, but you've got to understand, like, if APIs can be a siphon of data or a corrupt data, then you need to get a handle on that problem set.
Mhm.
And it's usually very easy to say, hey, our data needs to be not poisoned and or manipulated in any way in transit and or whatever. Um, and so if it is, it affects our bottom line. It always comes down to money, right?
That's true.
Feels
That's
like
true.
it.
I mean, there is a reasonable argument that all of information security or cybersecurity is really data security. That
Yeah.
ultimately, that's all you're trying to do. When you ask, the five whys methodology, if you keep asking
Hmm.
why, I like to
Yeah.
think of it as a six whys methodology. The sixth why is the one that is just a truism. For businesses, it's the sixth why is always generating revenue or protecting revenue. And then you
Yeah.
back to the fifth one and you understand, sort of the goal you can measure and accomplish that isn't sort of that truism. And protecting data, is sort of the fifth why in a lot of cases for most businesses, just before revenue,
Yeah.
if you will.
I
Yeah.
like that. So my mentor, back was actually in the Department of Energy, when I had to sit and, brief either what was going on, to AOs, so authorizing officials or whatever, and or talk to, Senate or Congress members or whatever. It was always the so what,
Yeah.
right? So you have to be able, like, because, especially as security professionals, it's like the sky's on fire, like the sky's falling, and like this is on fire, and all these bad things are happening. And so often people are like, so what?
Uh-huh.
Right? I remember one of my favorite demos was copying down, and we used Dave Kennedy's social engineering toolkit, and it was just a simple, stupid thing. But when we sat in front of this congressman and brought down his Facebook profile and showed that we could manipulate the data to, like, show he wasn't toting the party line, his face went white, like, but that wasn't even what we were trying to, like, accomplish. Like, we were
Hmm.
talking about how important it was to protect SCADA and ICS
Yeah. Yeah.
in our critical infrastructure. But the person that was like, because I didn't understand why I was doing the demo. I was like, why are we doing this? This is stupid. To
Yeah.
see that buy-in happen because the so what hit so hard. Like
Yes.
that's what this means. But because we're not making the right decisions, because we're not protecting ourselves the right way, we're
Yeah.
opening ourselves up for this.
Well, now I need to change the slide from define your outcomes to define your so what.
Oh, well, there you go
That's a good
then.
one. All right, so we've gone through all the stages. We've realized we have a problem. We've looked at our tools. We've checked out the key criteria, and we've understood our business outcomes or our so what. And we're kind of at the end of the stage there. I know we're also at the end of our time here, so I want to take a minute, if we can, 2 minutes if we have them, to answer questions. If anybody has any questions, feel free to put them in to the Q&A or into the comments in LinkedIn, and we'll pull them out. I do see one question in there now that I'll start with, which there was a it says there was a key criteria for automated remediation. Can you explain what that is? And I will do that because I skipped it. In the key criteria section, we had automated remediation as one of those criteria.
Mhm.
What we're talking about there is the ability to take some action. You could argue that blocking is an automated remediation task or action, but what I mean there is the ability to, generate an alert, connect to an integration that you have, to take some action outside of the tool itself. Understanding what can you do with those incidents and attacks that actually occur. That's sort of the objective of that automated remediation criteria. All right. Looking for any additional questions anyone has. I don't see any in there now. If you would like to download the white paper that contains most of this information, what we sort of built this presentation around, there's a URL there, QR code. You can download that if you'd like. And I'll finish off with upcoming WallArm events that we have. So if you're in any of these locations, Boston, Omaha, or perhaps you'll be at RSA, feel free to connect with WallArm. We'd love to see you. We'd love to chat with you. I'll leave that up for a minute. And with that, Jeremy, I want to thank you for your participation. It was interesting and valuable for me. My primary measure of the success of these webinars is, did I have fun and was it interesting? So I'll count this one as a success, but hopefully that's
Good,
true
because
for everyone else
yeah,
as
I
well.
learned a lot. I enjoyed it. Like I said, I think prior in the pre-meeting, I think we have a lot of other things we could talk about, but I wanted to make sure we stayed on point. But I was busting at the seams to just talk
Yeah,
about a lot of stuff with you. So yeah, I had a good time and I appreciate it.
that's great. Awesome. Thank you, Jeremy. And thanks for everyone for attending. Much appreciated. And we'll see you at the next event or next webinar.
Thanks.